Every day, thousands of hydrogen-powered forklifts move products through warehouses around the world. But before hydrogen ever reaches a fuel cell, it passes through an invisible network of tanks, compressors, cooling systems, and fueling equipment. Today, we're uncovering the hidden hydrogen machine behind every fuel cell forklift. When most people think about hydrogen-powered forklifts, they focus on the vehicle itself. But the real story begins here. This is the hidden hydrogen station that powers the entire operation. Every component you see plays a role in moving hydrogen from storage to useful work. Hydrogen arrives at the facility, is stored safely, compressed to high pressure, and then delivered to fueling equipment. At the center of this system is the goal of keeping warehouse operations running continuously. While workers see forklifts moving products, an invisible energy infrastructure is working behind the scenes. This station is the heart of the hydrogen ecosystem. Everything starts with delivery. Hydrogen is transported to the site using specialized cryogenic trailers designed to handle extremely low temperatures. Inside these trailers, hydrogen is stored as a liquid at approximately -253 degrees Celsius. When the truck arrives, operators connect insulated transfer hoses that safely move hydrogen into the facility's receiving system. Advanced monitoring equipment continuously tracks pressure, temperature, and flow conditions. Although the process appears simple, it requires precise engineering to safely manage one of the lightest and most energy-dense elements on Earth. This is the first step in the hydrogen journey. Once delivered, hydrogen must be stored until it is needed. Here we see the storage systems that serve as the energy reservoir for the entire facility. The large liquid hydrogen tank stores hydrogen at cryogenic temperatures, allowing significant amounts of energy to be concentrated in a relatively small footprint. Nearby high-pressure vessels provide additional storage capacity for dispensing operations. Sensors continuously monitor pressure, temperature, and liquid levels to ensure safe and efficient operation. These storage systems may look simple from the outside, but they represent decades of engineering development focused on reliability, safety, and performance. Storage alone is not enough. Before hydrogen can be dispensed, it must be compressed to much higher pressures. This is where the compression system comes into play. Hydrogen enters the compressor at relatively low pressure and passes through multiple compression stages. Each stage increases pressure while intercoolers remove excess heat generated during the process. The glowing blue flow path illustrates hydrogen moving through the system as it is transformed into a high-pressure energy carrier ready for rapid fueling. This hidden machine is one of the most important components in the entire hydrogen ecosystem, because without compression, fast refueling would not be possible. Compression generates heat, and managing that heat is critical. That's why every hydrogen station relies on advanced cooling and safety systems. Heat exchangers remove thermal energy from the process stream, while cooling circuits maintain stable operating temperatures throughout the facility. Safety relief valves protect equipment from abnormal pressure conditions. Hydrogen detection systems continuously monitor for leaks, and emergency shutdown systems provide an additional layer of protection. Most visitors never notice these systems because they operate quietly in the background, but they are essential for ensuring safe, reliable, and continuous operation. After storage, compression, and cooling, hydrogen reaches the dispensing system. This is the interface between the station and the vehicle. Modern dispensers are highly sophisticated pieces of equipment that regulate flow, monitor pressure, and accurately measure every kilogram of hydrogen delivered. Inside the dispenser are sensors, control systems, metering devices, and safety mechanisms that work together to ensure a fast and reliable fueling experience. What appears to be a simple fueling pump is actually a precision engineering system designed specifically for hydrogen applications. Now we reach the moment where hydrogen is transferred into the forklift. The operator connects the fueling nozzle to the vehicle's onboard storage system, and hydrogen begins flowing into the tank. Advanced controls monitor pressure, temperature, and fueling conditions throughout the process. Unlike battery charging, which may take hours, hydrogen refueling can often be completed in just a few minutes. Once fueling is complete, the forklift immediately returns to work. This ability to minimize downtime is one of the major advantages of hydrogen-powered materials handling equipment. The hydrogen journey begins with delivery and storage. Hydrogen is then compressed, cooled, and prepared for dispensing. The fueling station transfers hydrogen into the forklift, where a fuel cell converts it into electricity. That electricity powers motors, lifting systems, and warehouse operations. The only direct byproducts are water and low-grade heat. What appears to be a simple forklift operation is actually supported by an entire hidden infrastructure network. This is the hydrogen ecosystem in its complete form, a seamless chain of engineering systems working together to transform hydrogen into productivity. The forklift may be the most visible part of the system, but the real story lies in the infrastructure behind it. From delivery and storage to compression, cooling, dispensing, and power generation, hydrogen relies on an entire hidden ecosystem. And understanding that ecosystem is the key to understanding the future of industrial energy,